We have a quotient function, and to find the derivative, we're going to use the quotient function rule. So as a reminder, if you have f divided by g, to find the derivative of f divided by g, you're going to say this is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator square. In our case, f is equal to x squared and g is equal to the radical. So we're going to say here f is equal to x squared, which is easily, you can find the derivative of that function, f prime, which is equal to 2x. G is a radical that requires us to use the chain rule. So g is equal to the square root of 5 minus x to the fifth. To find the derivative of g, we're going to say, we know that the derivative of a square root is 1 over 2 times the square root of whatever inside. So we're going to say 5 minus x to the fifth here. But we have to find the derivative of what's inside that radical and then multiply here because we're using the chain rule. So we're going to say 5 minus x to the fifth prime. We need to find that part. We need to find the derivative of what's inside the radical. So I'm going to find the answer here. So this g prime is equal to 1 over 2 square root of 5 minus x to the fifth times the derivative of 5 is 0 minus the derivative of x to the fifth is 5x to the fourth. So I'm going to rewrite it nicely. So g prime is equal to negative 5x to the fourth divided by 2 square root of 5 minus x to the fifth. Now I'm going to plug everything into the formula of the derivative of a quotient function. So we have the derivative of y, or dy over dx, is equal to the denominator, which is g, the square root of 5x minus x to the fifth, times the derivative of the numerator, which is 2x, the derivative of f, minus the numerator, which is f, in this case it's x squared, times the derivative of the denominator, which is this hot mess right here. So I'm going to write it in red, times negative 5x to the fourth over 2 square root of 5 minus x to the fifth. Everything is divided by the denominator square, which is square root of 5 minus x to the fifth all squared. Now I'm going to simplify this expression further. So the first thing I will do is to remove the radical. When you square the radical, it's gone. So dy over dx is equal to, I will multiply this here and then I'll try to multiply here. So I will have 2x square root of 5 minus x to the fifth minus times minus is positive. And then I have 5x squared times x to the fourth is x to the sixth divided by 2 square root of 5 minus x to the fifth. Everything is divided by 5 minus x to the fifth. Again, I'm going to simplify a little bit further. Notice how I do have a denominator in the numerator. I will need the same denominator here, so I will be able to add the numerators together. To do that, I will need to multiply this denominator here and then multiply it in the numerator as well. So it will be multiplying with it and then dividing with it as if I did nothing. So this will be here 2 times square root of 5 minus x to the fifth. I'm going to multiply those expressions together. I will have dy over dx, multiply 2 times 2 is 4, and then the x remains inside. When you multiply two radicals that have the same amount underneath, you will remove the radical and you will have 5 minus x to the fifth, because a radical times a radical is equal to the radical squared, and the square removes the radical, and that's the reason. Over 2 square root of 5 minus x to the fifth plus 5x to the 6th over 2 square root of 5 minus x to the 5th. And then that is the numerator over 5 minus x to the 5th, which is the denominator. Now, since I have the same denominator in the numerator, I can add the numerators. So I will do that. And before I do that, I'm going to distribute the 4x inside. So if there is any like terms that I can add later. So this will be 20x minus 5x to the 6th, I distributed, plus 5x to the 6th over the common denominator, 2 square root of 5 minus x to the 5th. Everything is divided by 5 minus x to the 5th. Now this is dy over dx. I have a denominator in the numerator, and we know denominators belong together, so I'm going to bring it down to the denominator. So now that I have that, I can rewrite dy over dx as 20x. There is nothing here that I can add it with, and I notice negative 5x to the 6th and 5x to the 6th will cancel each other. So I will have 20x in the numerator. I'm going to bring this denominator down with the other denominator. So I'm going to have 2 square root of 5 minus x to the 5th times the denominator from the previous operation, 5 minus x to the 5th. And then I can cancel the 2 with the 20. So I will have 10x here. So the final answer is going to be the reduced form, 10x over 5 minus x to the 5th. I'm going to bring this to the front so it looks nicer, times 5 minus x to the 5th, and that will be the final answer.